Hi everyone, welcome back to lecture 9 in assembly level program for 8051. In order to program any microprocessor or any processor, we need to study about the different instruction sets because each processor has a different instruction set. There is a three-way to program any processor, that is a machine level programming and assembly level programming and programming in C. But in this lecture we are discussing only the assembly level program. So assembly level program which requires, it is mandatory to understand each and every instructions in 8051. That is all five types of, if you are able to understand all five types of instruction set, then only we can able to write the program in assembly level program. So here is one simple few programs we are going to discuss, that is assembly language program, that is ALP, assembly language program to interchange two 1 byte numbers, and another program is there that is for n 1 byte numbers. So first we'll discuss, because this is data transfer type of instruction. So in this data type of instruction we are going to exchange or interchange the content of one memory location to another memory location. So here is a procedure. So before write the program we need to initialize the inputs to the microcontroller. Here I am using a memory location 8000 and 8001 to load the memory, and that is a data, that is 8000 loaded with 06 data and 8001 is loaded with a 07 data. So first I will use the pointer register, because this is a 16-bit address. In order to address this one we requires a 16-bit pointer. We can't use R0 in order to use it as a pointer register. Therefore I will use DPTR 16-bit register to point the address of 8000. So once we point this location, the DPTR will points the location of 8000 and its content 06. Now the DPTR is pointed with the content, DPTR content is 06. So now I need to interchange the content, therefore I will transfer this DPTR content to the accumulator. So accumulator is a CPU register. In order to perform any operation we need to transfer the content to the accumulator only. Therefore I will transfer to the accumulator. Because we can't able to swap these two information, therefore I am transferring this 06 to a stack pointer, that is push 0E0. Once we will use this instruction, the accumulator content will be transferred to the stack location. Therefore this 06 is now stored in stack. So after that I will increment this location, that is increment DPTR, it will come to this location, and now I will transfer this content, because DPTR now pointed to the content of 07 and the location 08001. Now the DPTR again I will transfer to the accumulator content will be transferred to, that is the DPTR content will transfer to accumulator. Now accumulator has the value of 07, okay, and 06 is in stack pointer. Now I will transfer this accumulator content again to this 8000. Therefore I need to go back. Therefore decrement DPTR, the pointer register will decremented by one step. Therefore now DPTR is loaded with 8000 and its location content is able to copy this 07, because accumulator has 7. Now transfer the content of accumulator to a DPTR, and then after this operation increment the DPTR and use the pop instruction that means stack content 06 will be popped it, and it will copy to the accumulator first. So then once it will come to an accumulator, after that we can easily transfer that accumulator content to dptr. So once we copy the accumulator content to dptr, 07 will goes to 8000 location, and 06 will come to 8001 location. Here, in order to terminate the main program, we are using lcall 003. So this will also halt the program temporarily, or you may also use sjmp instruction of memory location, that is halt instruction. So that instruction also stops the main program. It is a lcall instruction is also a 3-byte instruction. We can able to halt the program. So this is assembly language program to interchange to 1 byte of numbers. Similarly, for if n 1 byte of numbers, so if this is the case for only a 1 byte of instruction, but if the bytes are more, how can we able to interchange the content? So that can be performed by using some counters. Here n number I have selected as a 3, so it is user definable. You can define n value as in this program I define it as a 3, that because I am giving the 3 input bytes, that is in 30 location first byte 03, in 31 03, and in 32 04 byte I am storing as a input, therefore I will use the counter 3. If you want to make it as 6 input, you need to mention the counter value as a 06. That's it. So I will configure that counter with the 03 value because 3 input. Okay. So after that register, because I will directly use the location internal memory location, not as external memory, therefore it is 8-byte instruction, 8-byte memory location address. Therefore I can use R0 as a pointer to locate the 30th location. At the same time I need to transfer to the another location. I need one more pointer, therefore I will initialize the another, configure the another pointer register as a R1. So now transfer the content of R0 to the accumulator, therefore this 02 will go to an accumulator, and after that push instruction, I will store the information into the stack and move the content of R1 to an accumulator. So R1 content pointer content will be moved to the accumulator. So after that the content of accumulator will transfer to the R0. 05 will transfer to location 30. So after that pop the instruction, that is stack which stores this value. So pop the instruction will retrieve the information content to the accumulator. Now accumulator content will transfer to R1, therefore 02 will be transferred to this location, and this content will go to this location, and then output we can see in 30th location 05 will come, and in 40th location 02 will goes. So after that increment R0, that means incrementing R0 will makes the pointer register will comes to 31. At the same time the pointer R1, increment R1 makes the pointer register will come to the next location, and this process will continues up to how many values are there. Here the 3 values are there. I have selected the counter 03, therefore 3 times this loop will execute, that means loop L, the loop location will be goes to this position, therefore the loop will execute up to 3 times. 3 times means, so 30, 31, 32 locations will cover, So after this program decrement jump if not 0. If the R2 value will get 0, when the R2 value will get 0, it will exit from the main program. So this is a program logic for interchange n 8 bit numbers or n 1 byte number. And the next simple program we are going to do, that is assembly language program to add two 8-bit numbers, or 1 byte number. So here also I have selected the two memory locations, that is 8000 and 8001 to store, that is a first byte and second byte. So I'm going to add these 2 bytes and store the result in 8002. If any carry is there, I'm going to store in 8003 location. So same here also, in order to store the carry, I will initialize the register R1 and pointer DPTR pointer to point this location, the first byte of the instruction, first byte of the memory I am going to store, DPTR hash 8000. Move. Next, the DPTR content will be transferred to A. Move X A comma at DPTR, and this content first byte I need to transfer it to the B register. Therefore, move B comma A. Then increment DPTR. It will come to 8001 location. Then move X A comma at DPTR. It will go to the content of that is A comma at DPTR. The DPTR content will transfer to the accumulator. After that, add A comma B. So once I got A and B register value, I need to add these two, and result will be transferred to the location 8002. So after addition, there is a possibility to get a carry. Therefore, if addition of these two, if any carry will be generated, it will goes to the next location. That means if any carry is generated, it will goes to this location. If no carry, it will jump to this instruction, that is increment DPTR. If carry is generated, as it is the increment R1, the carry register is getting incremented, therefore R1 value is become 0 1. If no carry, it will come to this line of instruction, that is increment DPTR. So DPTR value will goes to pointer register address will go to 8002, and the content of accumulator to the DPTR. That means the result of add A comma B will 37 result, it will be stored to DPTR 8002 location. So after that, move the content of R1 to A. If any carry is there, the R1 become 1. If carry is not there, it is as usual 0. If increment DPTR, that will comes to 8003 location, and move the content of accumulator, because each time we need to transfer to the DPTR, we need to transfer through an accumulator. Therefore, we are transferring R1 to at a DPTR. So move X at a DPTR comma A. After that, L call 003. So once the carry content will come to 8003, the program will get exit or terminated. So this is a way to add to 8-bit number. In the same way, we are performing the subtraction operation also. Here is a manual calculation of addition, that is a 2 8-bit number BCD number. Therefore, each digit 5 is represented with 4-bit binary pattern. 0101 is a 5, so F is 1111. So by adding these two, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 0 1, nothing but 2 is nothing but 0 1, 0 1 carry. So 111 is 1 1, therefore 1 1 carry, so 1 will come to this position. Again 1 plus 1 0 1 0 1 carry, so 1 plus 1 0 and 1 is carry. So this pattern we may call it as 37, 1 is carry. Okay, so 37 in the output we may see that 37 and 1 will come. Similar program for subtraction. So subtraction also we need to perform the same way. Here also we need to initialize the carry. Instead of carry we are using the borrow. Here is the 1 0 subtraction manual calculation of the 2 input byte, that is in 8000 location I have selected 73, in 8001 BD, and these two value I am going to subtract it. So this is 73 7 3 and this is B and this is D. I am going to subtract this value. So 1 minus 0, that is 1. So 1 minus 0 1. Here 0 minus 1. In binary system, if you will get a borrow, then this value will become 2, that is 1 0. So here there is no value in the neighbor stage, therefore it will get a borrow from this position. So once it will come to this position, it will become 2. So again I am getting one value from this one, so it will automatically this value become 1 and this value become 2. So 2 minus 1, that is 1, and here it is 1 not 0 because we got a borrow from this position, therefore 1 minus 1 is 0. So after this value is 0 now, therefore again I need to get a borrow from this position, then it will become 0 and this will become 2. So 2 minus 1 1, again it is 0, take a borrow from neighbor, so 2 minus 1 again 1. So now this is also 0, 2 minus 0, that is this is 0 itself, there is no need to take a borrow because it is a 0. 0 minus 0 is 0, but here it is a 1, this is a 2, 2 minus 1 1, 1 is a borrow. So that we can see in 8051 microcontroller program, there is move DPTR to 8001 location because we are going to subtract from this number, so we are 8000 location we are pointing this one. So move x a comma DPTR, that means accumulator content will stored with 8000 value, and move p comma a, increment DPTR, that means the DPTR will come to this position. We are going to point the second byte of a data. Then after that use the instruction for subtraction. We know that we need to use SUBB, subtract a comma b, whereas if any borrow is nothing but a carry. If any carry is generated, it will uses this instruction, that is increment R1, otherwise it will increment the DPTR and load the content to the DPTR, that is 8002 location, and if any borrow is generated, it will get incremented and it will transfer to the accumulator and increment the DPTR, and content of accumulator again transfer to this DPTR, so DPTR will loaded with the borrow, otherwise the program will gets terminated. So this is a one program to subtract two 8-bit numbers. So next we are going to study about we are discussing about the ALP, that is assembly language program, to find largest number and smallest number in an array. Here also we need to use some counters because 6 numbers are there in an array. Size of an array you need to mention it. Not 4 numbers are there in memory location, different memory location: 8000, 8001, 8002, 8003, 8004. So here I loaded with the inputs 06, 03, 07, 04 and 02. So here first we need to initialize the counter. That means 5 counts you need to mention it. We are using 5 counts, 4 3 2 1 0. So once it will comes to 0, it will get terminated. Therefore again start the program with pointing the register with 8000 location 06. So after that load the content to the accumulator, then move b comma a, that is the content of accumulator transfer to the b register and increment the dptr. It will come to the next position 8001. Then move the content of dptr to the accumulator. Now b register has 06, a register has 3 value. Now compare these two. Compare jump if not equal. Compare jump if not equal. Check whether these 2 bytes are equal or not. If they are not equal, that is a and b content is not equal, then it will jumps to the j and c location. Jump if no carry. If carry is not there, then it will go to jump if no carry, it will go to decrement jump if not 0. That means it will checks the counter value r1 is get decremented by 1. If there is not equal, jump if not carry, then it will come to the decrement jump if not 0, that is r1 get decremented, and it will again it will go to the main program, that is back address, that is this location. So again a and b values are, that is a and b values are again loaded, then increment the dptr and move the content of a comma at dptr. That means this will repeat until it will checks the highest number in a series in a given array. So the same procedure you need to follow for this find the smallest number. Here also I use the same instructions to find the smallest number. Here the same counter, because I have selected same 5 numbers. Here the only one difference is nothing but instead of jump if not carry, we are using jump carry instruction. That means, so jump if not carry instructions will be generated if the a value is lesser than b, then the carry will be generated. If a value is greater than b, the carry is not generated. If carry will not generated, it will go back to the address. In case the carry is generated, it will go back to the address. Then you can able to find the smallest number. So only JC and JNC will decide whether which is the biggest number and smallest number in 8051, this assembly language program. And next program, that is 2's complement in 16-bit number. So I will explain the logic only. So after that, by using the instruction, we can able to write the program. I will explain only the one program. So here I have selected 2 input, that is input of 2's complement of 16-bit number, that is 16-bit number, because 8051 able to load only 8-bit number. Therefore 16-bit number I will load it with the 2 different locations, that is 02 and 07. So lower order byte is 02 and higher order byte is 07. So this number is nothing but 0702. So complete 16-bit number. I'm going to do the 16, that is 2's complement for this one. So for 1's complement, it will be converted into F8 and HD. And after that, if we'll add +1, then it will become 2's complement. By adding +1, the 2's complement value you will get, that is F8 and FE. So in order to do that, I am going to load the value of 8000 to the dptr. So after that, transfer that content to A, and I am going to do first the complement for the lower order byte CPLA. The 02 is get complemented that means once complemented. So in order to do the complement, we are using CPL of A. So after that, move A content to R0. So R0 content, and that is content of accumulator, will load it to another temporary register R0. Now I will increment the DPTR and move that content to the accumulator, that is higher order byte I am going to transfer to the accumulator. Now performing the complement operation. Now higher order byte is get once complemented, that is converted into F8. Now F8. Then move the content of A to R1. Now I transfer the higher order byte to R1. Lower order byte is in R0. So now transfer that R0 to A accumulator, because we need to do the 2's complement for the lower order byte. Therefore I will transfer the content to the accumulator. Now add A comma 0 1. That means 2's complement I am going to do here. The 2's complement I will do it for the lower order byte. This lower order byte. This lower order byte is 2's complement, means addition of +1. Add A comma 0 1. +1 will get added and the resultant will be transferred to the DPTR. Increment DPTR, that means it will comes to this 802 location and the value will be loaded to that is FE. So here is some mistake, that is FE will be loaded to 8002 and increment the DPTR. Move R1 comma A. This is the time to load the higher order byte. Okay, higher order byte R1 to accumulator A, and if any carry will be generated. So during it to one's complement or 2's complement, some carry will be generated. If any carry possibility, it will be added to accumulator. That can be done by using IDDC A comma 00. No 01, it is 00. Carry will get added to the accumulator itself. So then content will transfer to DPTR. So F8 will be loaded to 803 and FE will be loaded to 8002. After that, the program will get terminated. So this is a procedure to find 2's complement of 16-bit number. And next type of program is I think logical programs. So logical programs we already discussed. Logical operators we already discussed in instruction set. Different logical operators or and XOR operations are there. So for that we can use ANL for AND operation, ORL for OR operation, and XORL for